Okay, factoring. This is a review of how to factor different quadratic functions. We're talking degree 2 kind of equations. Okay, so we always check for common factoring first. That's the best idea. Then check out all these other forms. Maybe it's a simple trinomial, complex trinomial, or a difference of squares. Who knows? So if you look at something like 2x squared plus 4x plus 10. Well, 2, 4, 10, I look at those numbers and I see, they're all divisible by 2. So I know I can common factor it. So the first thing I would do is figure out what they're all divisible by. Oh, it's 2. And then I would divide each term by 2. X squared plus 2x plus 5. Cool, check. And then I would look at what's in the brackets and I would say, can I factor that? Well, I identify it as a simple trinomial. It has 3 terms, x squared, x, then a number. There's nothing in front of the x squared except for a 1. So I know it's a simple one. So now I'm looking to see, is there anything that multiplies to 5 and adds to 2? Let's see, 5 times 1, that doesn't add to 2. And that's it. So no, I'm going with no, you can't factor this farther. So we're done. Let's try a simple trinomial one. Okay, let's say we had x squared plus x minus 12. Okay, so I know it's a simple trinomial. And now I just have to see if it's factorable. So I look for things that multiply to 12, especially like negative 12. And then I see if those things will add to give me 1, since that's the term there. So let's see, what multiplies to 12? I got 6 and 2, 3 and 4, 12 and 1. Can any of those make 1 with 1 being positive and 1 being negative? Yes. I think if that's negative and that's positive, it will add to 1. So once I know my numbers, I make 2 sets of brackets. Since we're starting with an x squared, I put x at the front, and then I put my numbers at the back, negative 3, positive 4. And that's how I factor a simple trinomial. Okay, let's factor a complex one. I should have made these up ahead of time. Okay, complex trinomials, they're still going to have your x squared, your x, and then your number. I'm going to make them all positive just to make it easier for myself. But they're going to have a number out front. So let's say that number is, 3. And let's say my number at the back is 6. Okay, I'm getting there. Okay, so let's make this 11. I think that'll work. Okay, so I know it's a complex trinomial. It's got 3 terms. It starts with a number that's not 1. Okay, so it's still going to factor into 2 brackets. And honestly, you could guess those numbers. I bet you I could guess them right off the bat. I know this is probably not the best strategy, but I know the front 2 terms have to multiply to give me 3x squared. So I know it's going to be 3x and x. I already know that because what else multiplies to 3x squared? Nothing. And I know the back 2 terms have to multiply to 6, and there's not that many options. So, you could honestly guess and just play around with it. You could be like, okay, 2 times 3. And then you just have to expand it fast in your mind. 3x squared, that would be 9x, 11x. Yeah, that totally works. Look at that. I guessed it in a second. But that's an easy one. I'll show you how to do it using decomposition. So using decomposition as your method for factoring, your first step is to multiply the first and the last term together, which gives you 18. So you're looking for numbers that multiply to 18. So 9 times 2, 6 times 3, 18 times 1. I think that's it. And then you want to figure out which of those adds to 11. The first one, 9 and 2. So now you're going to replace the middle term with 9x and 2x. So 3x squared, it doesn't matter the order, 9x plus 2x plus 6. Now you're going to do something called grouping, which is another kind of factoring. You're going to split your equation in half, and you're going to common factor each half. So what can I divide 3x squared and 9x by? I can divide them by 3x. And now I'm just dividing each term by 3x. So what do I have left from the first term? Just an x. What do I have left from the second term? 9x divided by 3x would be 3. Okay, then you're moving on to the next group. I am going to use a plus here. And I'm going to divide, I see that 2x and 6 are divisible by 2. So 2x divided by 2 will be just x, and 6 divided by 2 will be 3. You always want those brackets to be identical, otherwise you did something wrong. And now you're basically common factoring, although nobody ever really knows what they're doing here. They just do what their teacher tells them. But what you're actually doing is you look at your two terms and you say, what do they have in common? Ah, they both have an x plus 3. So you're common factoring out an x plus 3. And then you're saying, okay, what do I have left from the first term? Oh, just a 3x. Cool. Plus, what do I have left from the second term? After I pull out an x plus 3, I just have a 2. And there you go. That's a complex trinomial factored using a strategy called decomposition. Or look at, you could guess. So there's that. All right, and a difference of squares. That's the only one I haven't done yet. So difference of squares is easy to identify because it's only got two terms and they're separated by a subtraction sign. And as it says in the name, they're both squares. Like they could be square rooted to get a whole number. So let's say I have x squared minus 25. These factor into two brackets. They're kind of like trinomials without the middle term. And you can just square root each term. So x and x, 5 and 5, one's a plus, one's a minus. Yeah, they kind of work like as simple trinomials that have 0x as the middle term. So it's almost like you're figuring out what multiplies to negative 25 and adds to nothing, right? And they can work, like they can even look weird. Like even if you had like 1 minus 64y squared. That's still a difference of squares, it just looks weird. So square root of 1 is 1. Square root of 64y squared is 8y. Plus, minus. Boom. There you go, that's a difference of squares. So that's just a summary of all the grade 10 types of factoring that we learned.